English. I prepared before the presentation everything in English, but some technical difficulties, and we will need to do this presentation like the slides will be in Latvian, but I will explain everything in English.
Yeah. Nice to come.
Okay, cool. Yeah.
Thanks.
So we'll do a very quick crash course. So basically, the title will be basically our introduction to AI with the flavor of ChatGPT. For sure, you are all quite educated, but I hope that I have a little bit of edge being a little like a professor and trying to implement this in business for 10 years. So I will try to give you something new. So let's start by one of the favorite slides. I know some couple of people know this already, so please be cooperative anyways. So about what AI actually is. And to understand what AI is, this is the question up there. We need to know what Scooby-Doo is. I believe all of you should know what Scooby-Doo is, right? Yes? So we'll check if you know. So the Scooby-Doo is the dog, and he has a team, and they have this minibus school, right? And they catch the monsters. And then there is the ghost who is obsessing the hotel because in the night he wants to bring out from the basement some kind of hidden gold or something. And when they at the end of the episode, they always catch the monster, they tie it up, and then they take off the mask. And if you know what is Scooby-Doo, what is under the mask? You said you know what is Scooby-Doo. No, so there is a monster. There is this ghost who is not letting people getting the gold. There is the alien. There is the octopus. All sorts of monsters. They catch them. At the end, they tie them together, and then they take off the mask. And what is in the cartoon under the mask? Is there actually? Yes, thank you, Arthur. Yeah, there is nobody scary, right? There is no alien actually, and this is the metaphor, right? So, okay, gang, let's see who the advanced AI really is. And they take off the mask, and then there is if. Do you know what if is? Algorithm. Yeah, programming rules, right? So, lots of rules. So, let's do one quick experiment. I do this in university. Please be cooperative. We'll need to stand twice. So, please stand up, everyone. Please. I know I once was in one place where one student said, I didn't come to the gym. So please don't, let's do it, not do it. So those of you who understood the metaphor, sit down. If you didn't understand, I will explain again. Okay, let's see. Don't be ashamed. Okay, so half of you didn't understand. Thank you, sit down. Oh, okay, let's... So the metaphor is that there is this monster, right? And this is this advanced AI. So like ChatGPT, like Apple Siri, any kind of AI system. And when they catch it, they take off the mask, and it turns out not to be a monster. It turns out just a bunch of programming rules, lots of rules. Is it clearer now? Yeah. Okay, great. So let's do another round. Please stand up. So those of you who agree with this metaphor, sit down, please. Okay, so please don't be afraid. So any of you who didn't sit down, like any kind of why don't you think this could be exactly what it is? Like, do you have any ideas?
There are no if rules actually. It's just a huge neural network is trained not based on if.
Huge neural network. Okay, cool.
There's not based on the.
On the right, a lot of questions.
Okay, cool. Questions, response. Any other ideas? No. Probability is great. All of that is true. So basically, if I ask this question when I teach in Riga Business School, everybody sits down. If I ask this question to Riga Technical University mathematicians master's program, nobody sits down, ever. And because they know, and you will know, why last year, first time in history, 2 Nobel Prizes went for AI. And there is no Nobel Prize for AI, actually. So, and the truth is that all of these models have no rules at all inside there. So nobody programs this, they do that. And this is actually equations, exactly those equations which are inside ChatGPT. Basically, this is the ChatGPT, literally. See this n side, this is the depth, how deep you want your model, but there is nothing else there. So there is the there is the input x, and then there is y output, and the x is something that we type in, or what Sophie a robot sees, for example, and the x is the probabilities, as you said, like 90% hello, 10% goodbye, 0% left, 0% right, and so on. So, and the only thing you need to know is how to find these coefficients. If you remember from high school mathematics, if you put in the right coefficients there, and you put this in the loop, you actually would get a reasoning model, and this would work like a consciousness, basically. And this is exactly basically this whole thing. And the mathematics of these models, they were actually from early 90s. But in early 90s, everybody who did these models, like Jeffrey Hinton, like Jan LeCun and others, everybody laughed at them. They said, what are you doing? This is not going to work. And this was because at that time, the supercomputers was like my phone, and this is the picture of RTU HPC, where there's a lot of NVIDIA video cards. By the way, NVIDIA is like, like literally 10 years ahead of everyone else. There's no competition for NVIDIA. So NVIDIA, like these huge GPU resources, the same mathematics and the data. At the early 90s, data was 200 megabytes. Now we have 200 gigabytes. If you combine all of these three components, huge data, the huge compute resources, the same mathematics from 90s, which have been a little bit updated recently, you get from unstructured data, structured data. The 90s saying junk in, junk out is not true anymore. Nowadays, junk in, 70–80% accuracy out. If you have here like a little bit of labels, then you have 99.9% accuracy out. So, and that's what literally lots of startup companies, larger companies, previously they had to have 10,000 budget to label something. Now they can do the same labeling for 500 euros or something. So this is where we are right now. And it is actually what's possible nowadays, and this is actually happening. I have students in KTH Sweden where they do the fluid dynamics instead of physics rules, like physics theory, using the deep learning. So if we watch like how balls drop, the deep learning can discover Newton's laws. It can do any like discovery that human brain can do. So basically the history goes like that. That initially in 50s they promised these artificial neural networks. There was no mathematics, there was no data, no compute, and then in 80s and 90s they started to do everything with expert systems, with programming rules, like in those if statements. Then in the early 90s they were starting to develop these new methods, but they actually took off only about 2012, 2016. And this is like these 80s self-driving car. When you go in the room, it drives on you because nobody programmed that there is like a cowboy in the room. But these Tesla FSD, this is based on deep learning, and this is complete different game. So any of you have ever driven with Waymo or Tesla FSD? Nobody? You have driven. Yeah, I remember. Did you went with me in America, right? No, you didn't. You the different trip, yeah. But so, anyways, because I went with Tilda, so I think somebody was there also.
It was different,
Okay, good. Anyway, so but you will see. So the FSD is not autopilot; it is complete self-driving. And Waymo. So let me show you. I was in the like basically October last year in San Francisco, and oh right, you have no video. That's why I said about video. Anyway, so I will need to post them that. So they have these Waymo cars, and there's nobody sitting at the wheel, and there's thousands of those cars in San Francisco, and they're making every like couple of months more 1,000 cars of those, And if you walk around the street and we talked with some like senior people, they said that we prefer driving with this instead of human driven cars. They always charge us fairly. Nobody tries to screw us, and it works excellent without any problems. So when you take an app, you sit in, and in video you would see that it starts to drive 50 kilometers an hour immediately. If somebody runs in on you, like brakes quickly, and it is perfect. Basically, there's really very little accidents, and basically this technology is already ready, and this is only possible with deep learning, and we don't see it in Europe because Europe is over-regulated, basically. So, and the same is with Tesla FSD. I was in Denver. I put the coordinates where I need to drive, and with cameras only, it drove with 10 lanes with difficult intersections. All the time I did not control the car. So this is today. This is not tomorrow. This is today. Next Tesla car even don't have any wheel anymore. So, and this is how this happened is because you see the Nobel Prizes. And the funny thing is, this Geoffrey Hinton, who is the godfather of AI, they call him. See, he got the physics Nobel Prize, but he is a psychologist. So the best psychologists are actually the best mathematicians, and that has always been the case. And he developed this mathematical theory, how these all models work, basically. And this theory actually works like the natural causes, like the lightning strikes or like the water flows by the least resistance. That is how all of the AI deep learning systems work. Here's another great example how actually this is. So there is a popular data set in image space. So there is a Pascal walk. They have like pictures of horse, and there is one photographer who leaves the signature of down here. And if I'm adding for the train model picture with the car and that signature, it automatically thinks that's a horse. And this is because all of the AI systems work like that. They mathematically, with the partial derivatives, have the effect of least resistance. And the easiest way how to get the horse is because this woman always takes pictures of horses like brown, white, and so on. But she always have the same signature, the same pixels there. So the model thinks that is a horse, and if you take off the signature, it doesn't recognize anymore. So the AI, all systems, including ChatGPT, don't think like humans. They try to find from the data we give them the least resistance, basically. And the other thing here, what I want to highlight is AI, deep learning models are not black boxes anymore. So if you have specialists, they can do this. They can tell you where exactly the model is focusing and what is happening in the data. So yeah, let's quickly jump over. So this is like this fourth revolution where we are living now, and this is like new electricity. But so you would think that AI would be deployed on robots first. I think when I talk with many people, that they think that AI, robots, and things. So there is this example of Starship. Many of you might know from Estonia. I have seen them also in San Francisco. They have like 10 years, 200 million spent, and still like it's cheaper and more efficient to just give €3 for some student to give you the last mile delivery, right? So this is not the place for AI. The place for AI, what I want to argue, is actually here. So this is another picture from LinkedIn, where the person is complaining that AI took her job of writing blog posts, and she wanted that AI took the job of laundry and dishes. But this is exactly where everything is going. Where there is a money, the AI automates things. So, and the same happens in America, in financial markets. All of these are from this year, for gaming industry. And but the thing about this is, it is very hard right now to predict exactly how this will pan out, but it's sure that this will affect the high-paying jobs. So here is the 2020, this was, I think, Goldman Sachs report or Forrester, the jobs least likely to take be taken by AI. So this is before Gen AI. Before Gen AI, everybody thought that artists, musicians, therapists, doctors, lawyers, they are safe. But you already know what happened next, right? So this is Forrester report from this year. Most likely automation, legal work, artists, office workers, computer scientists, programmers, and the least likely are basically construction, plumbers, and things like that. So this is actually reality. So, and I see that any place where I go, with the highest opportunity for us to make money is to automate the most creative, most expensive jobs, and this is where we are going, basically. And if you think that we are right now in Gartner hype cycle in the very top, I would want to argue with you that we are in the very bottom here, basically. So if you have seen many startups saying AI, 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 the thing is that actually where the money meets the road, like the rubber meets the road, we are very far away from where we will be. So this is the Gartner hype where basically new technology comes around, disillusionment, and then a productivity plateau. But what about AI? So the AI US adoption rate in the businesses, it's about like 20%. And this will be the same like internet and smartphones, but it will be faster. And so in Europe, we even have much worse situation. This is from 2003, 2004. Just last year, the Baltic states are really extremely laggy. So basically only about 8% companies last year bought anything related to AI. So in the company software products, only 8% companies bought something related to AI. Year before that, it was 5%. So, and the best ones in Europe, it's Denmark, Sweden, but basically they are also far away from where we could be. So it's and the reason why this is the Norstat survey in Latvia, 800 companies last year, late last year, November. So it is said there that have you tried to apply AI in your company? And 70% we have not applied and we don't think about it. So 18% we want, but we don't have. So 90% have nothing. In Latvia, in Baltics, in Eastern region, no AI whatsoever. So then do you think that AI will change your work? 36% of 800 companies say yes, that it will significantly change. 26, a little bit. So over 60%, they know that this will come. They have tried. They know what's coming. So, and why they're not doing anything, it's that 60% don't see how they can use it, and 21 don't care about it. So those 21 will die for sure. So, but 61% needs to be educated. So, and the reasons why we are so slow, and I'm trying to also bring a point, if any of you are in the circles of like influence, is that we are living in extreme over-regulation. Basically, I know myself, I later will do in the pitch session a little bit of my products and my experience where we work with banks, we work with the financial sector, with all sorts of companies. So that, like telcos, so telco TET in Latvia received 1.2 million penalty for GDPR, like in compliance, but this actually also was not that. So basically, they made it example of that, and now every company where I come with AI says we don't want to do this, get this, and they have like huge due diligence, like it takes months, like half a year. So, and in America there is nothing like that, and everything goes much faster. So, and the same now comes with AI Act. So with AI Act, there is also lots of strange things, but basically the high-risk solutions will have the same certification as you guys with the crypto. So do you issue certification from your association?
No, actually not. It's from the regulator.
Okay, in Latvia, we have association actually, And we are planning to issue also certification from association. There's a couple of also AI-related companies here in the room. We know that this is coming, and we will try to adapt with this, but this is definitely not good for business. So anyways, Europe is very bad for AI, so that's why I'm also, you will see later in my pitch session what's our plans. So just towards the end, let me show you something more interesting, like the flavor of ChatGPT. So the elephant in the room. I want to leave you with at least one valuable, actionable thing from today. So the ChatGPT just took 2 months to get 100 million users. In comparison, TikTok was 9 months. So, and even afraid to ask, like, how many of you use the paid versions of GPT? Yeah, Andre, you are much more advanced. Like, where was the last place? Okay, I was invited in one of the political party events that they wanted to like show about AI, and when I asked this question, nobody raised the hand at all. So basically, if you use these paid versions, you already have access to AI models which have higher IQ than the average human. Basically, and the OpenAI is rumored to release even more powerful agent systems that will cost thousands per month, that will be able to handle lots of work. So, and these systems actually work, they're based on transformers, and they work like this, and these are these few last nuggets I want to give you. So it's that all of the generative systems work the same way. So you give some kind of input in the beginning, and then you get some output. And the more input you give in the beginning, the better control for the output you will get. Like, for example, if I smudge something here, I get 0, 9, so on. If I write something like that, I will always get 8. And this is a very key information. This was the same for ChatGPT and for any systems. So there's an example. So there is a Latvian history question, and I asked like something about 1920s events, about there was a reform for agriculture. So, and this is like a normal high school question. If I put it in ChatGPT without the information search functions, I will get something like that with the one number and lots of water. So if I'm a history teacher, I will give like 2. So this is bad. So what you actually need to do, you need to collect real data. Like there is the 93,000 like these farms and so on. So you put the data in the prompt, and immediately you get a very high quality result with all of these same data you just gave. And this is actually the same type of system how all of these RAG systems work, it's just manual. So basically, this is 10 times more important than writing the right questions or anything like that. So this is the Brockman, a CTO of the president of OpenAI. So, and he posted in February his template, and this is the same as I'm showing you. So that there is the prompt has the task, return format, and the context dump. And if you don't add context dump, you will have bad results always. So either you can use the maybe search result. So that is the kind of practical aspect you can take from today. But to have more. So just a few nuggets here. We had 2022 the large language models. Now we have the RAG systems. So how many of you know the RAG systems? Okay, I know Arturs knows, Andres knows, but many don't. So let me explain briefly about RAG. So the RAG is the way how not to spend hundreds of thousands of euros of training models. You don't need to train models at all nowadays. You have one language model, and you have another model for the vector databases, embeddings, and so on. So what you have your own knowledge base, email, CRM, ERP. You pass it through that first brain, produce these embeddings, and when you ask something, you find the right place, you put it exactly the same way as I showed you manually, but automatically. And immediately you get high quality answers about like real-time data from your company and everything. And if you have this use case, you can apply it so many ways. So, and that's why everybody is saying we're going to these agents. So, yeah, if you want to try out, you can try it in OpenAI, ChatGPT, and Perplexity, also in the Google notebooks. About the search engines, I have not used Google literally for a year. So if you want to use something better than Google, there is a Perplexity, for example. There's an AI for that, which is the way, about 10,000 AI tools you can browse and look up. And if you want to find out more, I have also a podcast. Yeah, so that's a quick intro. Thanks.